Howdy, AP PreCal. As promised in the last video, I was going to do number 4 and number 5 as inequalities. I took this set of notes, and anyway, number 4 ended up being grosser than I expected, and I don't remember what number 5 does. So I changed my worksheet on equations to have a couple inequalities just to practice that. But this one did not serve me well. Anyway, go watch that other video. I'm very sad and whatever. No, I'm just kidding. Okay, so here's, fingers crossed, 5 works better. Okay, so when I see this, I'm going to come in and see what happens when I set them equal. And I notice that I have a cosine and I have a sine, and that's no good. I can't keep both of those things. So this is 1 minus sine squared plus sine equals 1. The ones will cancel. I have a negative sine squared theta plus a sine theta equals 0. I could move it to the other side, so my leading coefficient is positive, but I can also just factor out a negative sign, and I'm left with a positive sign minus 1. And then, okay, if negative sine equals 0, sine equals 0. So this, the first thing here is that sine of theta equals 0 or sine of theta equals a positive 1. When does sine equal 0? Sine is the y value, so sine equals 0 here at 0 and pi and 2 pi and 3 pi, and etc. But all we care about is from 0 to 2 pi. So this theta was equal to 0, was equal to pi, was equal to 2 pi. This one, sine is the y value. Where does it equal 1? Up here at pi over 2. Oh, already this is a better problem than the last one. Okay, I'm going to come over to this space, but I'm not about to do this one as an inequality. That would just be, I mean, I'm mean, but that's pushing it. Okay, well, partly because I don't want to work that problem. And if I don't want to do it, then that tells you everything you need to know. Okay, and I wanted pi over 2 on my number line. Okay, so let's pick something in between here. I'll use pi over 2. So if I have cosine of, I meant pi over 4. I said pi over 2, I meant pi over 4. Okay, plus sine of pi over 4, and I want to compare that somehow to 1. So when I started, I know these are the same kind of problems, but I just started writing it this way. When they got a little bit more complicated, I put a question mark here. Okay, cosine of pi over 4 is root 2 over 2. And we're going to square that plus root 2 over 2, and we want to see how that compares to a positive 1. Well, root 2 squared is 2, 2 squared is 4, so 2 over 4 is 1/2. This is 1/2 plus root 2 over 2. Well, how does that compare to the number 1? This is 1 plus root 2 over 2, and it's going to be bigger than 1 because root 2 is bigger than 1. 1 plus 1 would be 2 over 2 would be, does that make sense? If this were equal to 1, and I had 1 plus 1, that would be 2 over 2, which would be equal to 1. But this value, root 2, is bigger than 1, so this numerator is going to be bigger than 2, which makes the whole fraction bigger than 1. Yay. Okay, so that meant that this value gave us a true statement. Right in here, we're going to be true. Okay, so let's see what happens when we use, if I change this to a 3 pi over 4, then I have cosine of 3 pi over 4 is a negative, yes, that's over here, you can't see it, negative root 2 over 2, but when I square it, it still becomes positive. Sine is still positive in that quadrant, and so this is going to behave the same way. Am I right? I think so. We're going to have to go check on the calculator. Okay, let's pick for the last one. Let's pick 3 pi over 2 because that would be easy to work with. So cosine of 3 pi over 2 quantity squared plus sine of 3 pi over 2. How does that relate to the number 1? Well, cosine of 3 pi over 2, 3 pi over 2 is here. Cosine of the x value is 0. 0 squared is still 0. Sine is negative 1. Okay, so this is going to be less than positive 1, and that is what we wanted. No. Oh, you guys, okay. Did you catch my mistake before I did? If you did, good job. Comment down below if you caught my mistake before I did. And comment down below if you stuck around to the video to see this part. I had initially wanted it to be less than, and so then I was getting things to be greater than, and then I said it was true. Well, that's false. Okay, so change this. This should be false. This should be the same thing. This should be false, and this one should be true. Okay, so now let's go back to our calculator from before. I would probably use Desmos, but it doesn't film very nicely if I'm working like this. Okay, anyway, you're fine. So I have, what do I have? I have cosine of x quantity squared. Yep, that's not what I wanted. I can just hit squared. There we go. Plus sine of x. And I want to compare that to the value of 1. Oh, and I probably need to adjust my window. Okay, let's see. Window. It looks like my y values are probably okay. I need to go from 0 to 2 pi. So that's 6.28. So let's go from -1 to 7. And see if that gives us a better situation. Oh, that's weird. Who knew? Okay. Let's do G solve. We needed the blue, the first equation, to be less than the red. We need the blue below the red. You know what? I'm going to change my window again. My y values, I want them to be more like 1 to 2. Let's see if that's reasonable. No, I needed to be below 1. Here's 1. That was silly. I knew better. Okay, let's go back to window. I want it to go from 0.5 to 1.5. That's what I really care about. My bad. Okay, so when I graph that, okay, so now, what did I say? I wanted the blue to be below the red, and so it's going to be between those. So I need to do G solve and come find those intersections. I don't need that one. Oh, it's making the calculator think. I don't need that one. I bet that's pi over 2. I want this one. That looks like pi, 3.14159, okay? And then this over here, Desmos would tell me in terms of pi, that looks like 2 pi. So our answer is what we expected over here. Our answer to this problem, where do I want to write it? Right here. Our answer is pi to 2 pi. Hallelujah. Okay, subscribe. Keep watching. Ask me questions. Go practice, practice, practice. Good luck to you.